This demonstration of drill down uses this particular data set that you can see behind the form. It's been built with Visual Studio Windows Forms application in .NET, and it interrogates this data in a text file by getting a list of the individual names, or unique names of the units, which are here, and selecting a unit, and that's just a debug message. And then based on the introduction to this column here, it then looks up the various learning outcomes that are there, understand hardware requirements, and hardware requirements has 3 topics associated with it, and those are the 3 topics. And that's the same sort of thing as we're going to do, but this time what we're going to do is we're going to base it on a different data set, and we'll build it from scratch, teaching you how to do that. And that's going to be with cars data. Instead of units, it's going to be manufacturers, models, and spare parts for the cars. And that's what we're going to build. The structure that we use in data is different, but the process that we go through is exactly the same as you saw before. And the same achievement will be made, is that you'll be able to select a manufacturer, and then select a model, and then select a part. And that's what this application will achieve. So let's get started on building it. So open up Visual Studio, and we need to make a new application. So it's a new project, although it's in fact a project inside a solution. We're going to do it this way because this is going to be the simple way to do it. And what we're going to do is select V#, C#, Windows Desktop, Windows Form application. I'd like to do it in WPF, but it would just take too long. Now, an alternative way to do that, of course, is that if you've got templates up here, if you've been using this particular template before, it'll be sitting there, exactly the same dialog that you get. And I'm going to call this one Car Parts, and it's going to be in my D drive in a folder called Car Parts. So that's what we've got there. So we simply click OK. And it makes the solution for us. So here we are on the right hand side in the Solution Explorer. This is just finishing off. It's actually quite a lot of work for it to do when it's making it. So we've got our car parts, and because we made a Windows Form application, it comes with a built-in form, which is their Form 1. And if you wanted to have a particularly bespoke name for that form, now would be the moment to delete it, recreate it, and then change the startup form in Program CS to whatever you'd call the new form. But we're not going to do that. We're just going to work with Form 1 because it's easier in this particular set of circumstances, because that's not the focus of this particular exercise. So there's our program application. We've got Form 1. Now we're going to add some classes that are going to be used to work with the data file and to manipulate the data that the data file contains once it's been imported into the application. One of the last things we'll do is design the control interface on the GUI. We're going to start on the classes first, so let's just do that first. Now, how do you do that? In our project, not the solution, in our project, right click, add class. Now the first class is going to be one that's going to be what I would call a kind of a factory class. I've used it again and again when working with text files. I wrote it a very long time ago, and it's just been invaluable when you're using that. It's called ImportData. So we add that class, and the first thing we do is make it public. So you go to the word before class and make it public. Now that's now a public class that's going to be available throughout the whole of the application. This is not a lesson in OOP, but I'm going to have to dip in and out of some of the things that we do in OOP to help you understand why I'm doing what I'm doing. So a public class is going to be available throughout the application. Now let's add the second class, which is just going to be called utility. And the purpose of doing this in one way is to teach you that one of the great values about doing object-oriented programming is that you separate things so that things can be worked on their own and be treated as separate concerns and maintained on their own as separate concerns, so that when you have a change in this class utility, It doesn't change any other class, but what we do in here is then going to become available to other classes when they need to use what we've done. So we'll start with public class utility, and what I'm going to do is I'm going to actually just code. I've got the code ready in a different application, and I'm just going to copy it from there and paste it in there and explain what it is. And I'll make all of the code files available in a GitHub, and you'll be able to do that at the end of the last video. Or maybe I'll do them beforehand, I'm not sure. So the first method I'm going to be making is called shutdown. And now what it's going to do is it's going to close all the open windows, and I'm doing this now to show you that it's probably better to put this sort of utility in one place so that you can repeat this again and again when you make more and more forms in your application. So I'm going to make it public as a method. I'm also going to make it static. What that means is that it can be used directly as a member of the class without creating a new object of the class, and we'll show you how that happens in a moment. Please don't worry about the terminology. So I'm going to say that it returns void. It doesn't return anything, it just does thinking. It does stuff, and it doesn't return a value back to the application. Shutdown. Parentheses and braces, and we now have the framework for our class, and that's our class. So what I'm going to do is I'm going to just copy the code as I said, and I'm going to paste it in here, and you'll then see as I walk through it what this class does. So we've got a red line. That indicates to me that we're using some words which don't have definitions in the directives of this class yet, because this defines what the class can use, and we've suddenly gone, form, what's a form? So what we need to do is, in many cases, the application will have a thing to do that, and it's imported the Windows form straight in there. Now no red lines, everything is valid in terms of what this class knows about. So we're going to have a list of forms, which is a new list of forms, and then all of this list needs to be navigated through line by line by line so that we can deal with each form separately. So we use what's called a for each. For each form F, that's just the name while we're handling it. In application open forms, that's all the open forms in the application. We're going to do for this list here, add this one we found. So any application that's got any open forms that we find will be added into the list. Then just go through this list for each form F, close it, and all the application forms will close, and the application will close too. In good practice in programming, you would always add comments that say, well, roughly, just very, very, sort of succinctly, what any one application will do. So the way in which we to do that is very easy in Visual Studio 2.3, and it gives you an outline for putting comments in. So this is a method that will shut down all open forms, and that's all you really kind of need to do, because it's very, very straightforward to do that. I just copied that something in by mistake. So then what's always good to do is, having got that, do a build. And it's build succeeded down here in the bottom left corner. So you've made no gross errors. Now the second method I want to put in here is very, very easy to understand, I think. And I'm just going to copy that in for you from my clipboard. And this is called string found. Now this is an application method that's going to be available in lots of different places, because we have to look in lists of strings to make sure we're not duplicating items. Because remember, there are several parts with several models with several manufacturers, so it'd be really easy to get that wrong and repeat the name of a manufacturer, for example, when in fact you only want to appear in the combo box once. And that's what this method is going to help us to resolve, is to make sure we get individual elements rather than repeated items. So that's our class utility complete. Let's just run through this here just to help you understand. So public static bool. So this is going to return true or false. And we're going to say the name of the method is string found, and it's going to have a list to look through. List of strings called list to search, and you'll see that in use when we get to the code. And then a string which is going to try and find in that list. So we first off set the string found to false because it's going to be false. We'll assume false, that it's not there at first. And then what we'll do is we'll change that to true if we do find it in the list. So for each string value in the list to search, which we've given it, if value is equal to string to find, the one we're looking for, then string found equals true, reverse that, and return string found. So it will immediately drop out, say I don't need to look any further, I found it, so I'm going to say that it's going to be drop out of that 4. So it goes through all of the lists of the strings in all of the lists that it's got to search, and it can do that really quickly, really quickly. And then at the end it returns whatever the current value of string found is. So that's what string found is for, is to make sure we only get the name once when it appears several times in a list. So let's finish off this class. One good thing that you can do now in Visual Studio is with the usings, it doesn't really help very much, but it makes your code perhaps a little bit clearer, is you can remove any unused directives. And only the used directives for this class that are currently in use will remain. It doesn't really do anything in terms of efficiency or speed or anything like that, but it just makes it easier to read. Now what I'm going to do is also introduce something that I think is very good practice. In my text editor that I use, which is Notepad++, I keep a page open that I have sort of a template for things that I always kind of use when I'm programming. And one of the things I like to do is that at the top of a module of a class that I've created myself, not necessarily any code that you're building on from what's been done by Visual Studio, I'll put a header, and that's what I put in here. And this class information should be, this is best practice. This should really be part of every coder's sort of toolbox, that they should be able to do this at the top of every class. Because what it does is it helps you understand what you did, and it will help you with the maintenance of your application later on when you have to review or change or add things to it. So I put the name of the class, and this is utility. And that just helps me to know what that's called. The author is me. Paul McKillop. Created, now that's the date, and today is the 15 January 2019 already. And the purpose, not purpose, I meant to fix that before. Purpose is provide methods to the application. Provide methods to the application, and that's it. So I've now got a header, and you would maybe, if you updated the file, you would maybe do a comma, updated and stuff like that, or you change the date, whatever you choose to do. But that's really good practice in making classes clearer to understand for you and anyone else that has to maintain them. To finish this video, I'm going to work now with the class ImportData. Now, I'm not going to attempt to explain this in detail because it contains some quite sophisticated bits of code, especially to do with regex, which is the way of which you can pattern match the types of characters that are allowed in a statement and so forth. But I will explain its purpose. So first thing I need to do is going to need several directives that aren't included presently within the class module by default. And those are those, using system.data, system.io, and system.text.regular expressions. And that's the one that might have caused you the most confusion if I attempted to explain it. But let me explain the purpose of this. I'm going to put the code in first, and then you'll begin to understand just what it does, not how it does it. So in here, I'm just going to paste the code, and there's all the code. Right. What it does is a text file is a very useful way of transporting data in tiny small files. And if you have a CSV, a comma separated values text file, then you can absolutely in C# you can use a thing called split and tell it to look for the commas and split the file by the commas when it finds them. Absolutely, you can do that, but it's not very convenient. What the method I'm going to use is, and it works very, very well as long as the number of items in each line is consistent. It's going to be really efficient, and it will handle nulls if there's only 3 and so forth. But what you can't do is you can't miss a record in the middle. But this is really cool. It takes this text file and it turns it into something called a data table. Now, a data table is a bit like a spreadsheet. It has rows and columns, but the columns are called fields. So what it does is that it says, I want a data table coming back out of this method, and my method that I'm going to use is called getTextFilePath_FileData. And it needs the only one thing to work with, and that's where the text file is, and that's the string, which is the path to the file. And in my case, it's d:\cars data. So that's what I've got here. And then this, it says it starts up a reader, and it reads through all of the things that are in the text file. And it says, okay, let's get the headers from the first row, and that defines the number of fields that there are. So I'm going to have manufacturer number, manufacturer name, model, and parts, I think it is. That's the 4 columns that I've got, the 4 fields that I've got. So then we initialize a data table and say, go right through all of the data you've got and put this into the right columns. That's all this is doing here, and it's using the comma or any of these other expressions that would be valid for splitting up the records in a text file. Having gone through all of them, it keeps adding them until it gets to the end, and then just returns that data table as the output from that function. Now, it's a lot to take in, but just bear with me. It takes a text file with a consistent number of columns in the data, and returns that as a spreadsheet-like structure that we can then go through row at a time, and then when we get to a row we can deal with each column in that row and so forth, and you'll see how we do that as we move through the data that's in the text file to get the manufacturers, to get the models and so forth. So that's what that's for. Now I'll give you the code, of course, and you're going to get that very, very much so, but I'm not going to explain it in any more detail. So in the next one we're going to move on to a different couple of classes, and we've got one called car data, and we're going to get another one called lists.